This video is covering section 7.2 in our textbook, and we're starting to talk about trigonometric identities. So what I did with the notes is I included the identities that we're going to be using, or at least some of the basic ones that we're going to be using. Now, the homework for this section, there's two homeworks, so we're going to do this over 2 days. So the first homework assignment, this 7.2.1, is not actually doing any identities. It's kind of more similar to the homework from 7.1, where they're just trying to get you to simplify some of the trigonometric expressions that were given. The second homework, 7.2.2, that's really the ones that are going to be the kind of proving the true identities like we're going to do here on this video. So again, the first part, that's the first homework assignment. That's due, that will be the first homework assignment, and then this will be the second. But this one, not really doing the proving identities like we're going to do here in these paper, on the paper copy of the notes. So one more day sort of just basic simplifying trigonometric expressions before we get to the true identities. Okay, so I kind of reproduced the identities and notes portion from 7.1 that we just went over. We have the reciprocal identities, we have the quotient identities, and then we have the Pythagorean identities. So these we'll use a lot. These we don't use so much, the even and odds identities, but I mean, these are useful. For example, if we have the sine of negative x, we can get rid of the negative in the x by just saying, oh, that's a negative sine x. And if I have cosine of negative x, well, I can just get rid of the negative entirely because that's even. I can just replace it with cosine x. So sometimes those might be useful. I don't think we're going to find these as much in our identities as the reciprocal, the quotient, and the Pythagorean. Okay. Also, if we look on page 661, it has some good ideas of what to do. Some beginning points, like when we start these identities, what would be good things to look at. So first of all, you should learn your identities. You got to memorize them. And you also have to be aware of the alternatives, right? So we know hopefully you know sine squared theta plus cosine squared theta is equal to 1. But with a little algebraic manipulation, I could move the cosine squared over, and I know that sine squared theta is equal to 1 minus cosine squared theta. So there's alternative sort of forms of this identities and the other ones as well. All right, so that's one thing to do, is make sure that you're aware of all of the identities and you've memorized those. For now, at least have the list sitting out in front of you while you're doing your homework. All right, so we always, when we're getting to identities, what we're going to do is we're going to try to take this expression and turn it into this expression. So we want to show that these two sides are equal. So we'll take one side and manipulate it until it's equal to the other side. And so basically this list on page 661 is some things to take into consideration and think about when you're doing these. So first, we want to work on the more complicated side. It's easier to turn the more complicated side into this simpler expression than take a simple expression and turn it into a more complicated expression. So always rewrite and start with the more complicated side. Sometimes it's a toss-up. They both look complicated. But if there's one that's more complicated, start with that. All right. It's sometimes useful. So if you're like not sure what else to do, like you don't see any identities, to turn everything into sines and cosines. So use identities to turn things into sines and cosines. Turn a tangent into sine theta over cosine theta, whatever. Turn everything into sines and cosines if you can't figure out anything else. Also, we're going to have to do some algebraic operations. We factor or we FOIL, some of those kinds of things. So we know we have a a perfect square trinomial, right? So we'll, knowing these kinds of things will be helpful because some of these factoring things, either we start with this side and we multiply it out, expand it out into this, right? Or sometimes we have a trinomial and we want to factor it. So be aware of these. These are things we've already done, right? Perfect square trinomial with a plus, perfect square trinomial with a minus in the middle term, difference of cubes, sums of cubes, difference of squares. If you know these, those will show up sometimes, all right? So if, we could do it with x's and y's, but we can also do it with trig ratios. So sine squared x plus 2, sine x plus 1, well, that will factor. And it's essentially a perfect square trinomial with a plus sign in it. All right, so this is really equivalent to this, where x is sine x and y is just 1. Okay, so be aware of that. Sometimes, like for example, this, we might want to add these, so we have to get a common denominator. So multiply top and bottom of this fraction, this quotient by cosine, multiply top and bottom of this by sine, and we get sine theta cosine theta as our denominator. So we're going to have to do some algebraic manipulation sometimes. All right. I'm not sure, this one's probably not super helpful, this suggestion. We're going to be working on sort of one side at a time. So don't be trying to manipulate both sides. So just one at a time. And then sometimes multiplying top and bottom by a conjugate is helpful, and we'll see that in some examples. Okay, so anyway, that's sort of a list. Underneath this list, it says verifying identities by working with one side. You'll see if we page ahead, there's also a version in our book where they say verifying identities by working with both sides. We won't be doing that. We will only be working with one side of the identity. That's typically what they will have you do next year in Trig Calc. So we're sort of holding to that same sort of process, even though just know that it is possible you could, in theory, work on both sides, but not in this class. In this class, we're going to expect that you are working on just one side or the other of these identities. All right, so let's look at number 1. So number 1, secant x times cotangent x equals cosecant x. We want to verify this identity. So what we want to do is start with one side or the other, manipulate it using identities, using algebra, and turn it into the other side. So first, we want to start with the more complicated side. This side appears to be more complicated. So sometimes, depending on the problem, it's not as obvious which side you're starting with. So I'm going to request that you do left-hand side, and then, left-hand side, and then you can start manipulating it. You don't have to rewrite this left-hand side here. You can just start changing things. So, one of the things that we do is do you see an identity here? I don't really see any identities. I have some secants, but it's secant squared, and I have some cotangents, but those cotangents squared, and that's not what we have. So I don't really see any identities per se. What we should do is probably, in this case, don't know what else to do, turn it into sines and cosines. So secant could be written as 1 over cosine x times, and then cotangent is cosine x over sine x. Notice I'm just manipulating the left side. I'm ignoring, not putting equal sign here. I'm just going to work down. So what's this equal to? This is equal to, I could cancel the cosines, or I could say, if I wanted, cosine x over cosine x sine x. Now, most people would look at this and say, oh, the cosines are going to cancel, probably skip over this step and go straight to, well, this is 1 over sine x. If you ever ask yourself, oh, should I write down that step or should I skip over it? Probably safest to go ahead and write it down. So if you're asking yourself, should I include that extra step or can I skip it? If you have to ask yourself, you probably should just go ahead and write it down. I'm giving you the answer, right? I'm telling you what the final thing is. So just because you wrote that down at the end doesn't really mean a whole lot, doesn't get you a whole lot of points. So it's like when you did two-column proofs in geometry. What you were trying to prove was always the last step. And so it's like, oh, that's a no-brainer. The last thing I got to prove, the last thing I got to write is what I'm trying to prove. So same kind of thing. I know at the end I'm going to say cosecant x, but that's because 1 over sine x is equal 1 over sine x is equal to cosecant x, which is my reciprocal identity. All right, and so now I say, oh, okay, well, that's equal to the right-hand side. I'm done. Okay? So first you're telling me what side you're starting with. So either write LHS for left-hand side or RHS for right-hand side, telling me what side you're starting with, because we don't always just rewrite that side. We can go ahead and start manipulating it and rewriting it. Sometimes it's not obvious if you start manipulating it, especially if the number of steps is few, there's few steps, then it's sometimes not very obvious. So always write left-hand side or right-hand side to say what side you're starting with. Okay. All right, let's go on to number 2. All right, so we want to look at these two sides and say, okay, which side is more complicated? And sometimes it's a toss-up, but I think we'd all agree that probably the left-hand side looks a little bit more complicated than the right-hand side. So I'm going to start with the left-hand side. And I'm going to go ahead and turn this secant into, now what I would suggest you're doing with these is pause the video and then try these on your own for each one, right? And then once you've sort of attempted to turn one side into the other, in this case, this is the more complicated, so we're going to start with this, try to turn this into 1 plus tangent theta. When you've done that, start the video back up again and check and see how you did it. More than one way to do it too. Just because I did it a different way than you did does not necessarily mean it's wrong. So long as you're not violating any rules, you're not making stuff up, so long as you get to this other side at the end, you're good. Okay, so this time I think I'm going to rewrite secant using the 1 over cosine theta is equal to sine theta plus cosine theta. So turning everything into sines and cosines is sometimes a good approach. And if I distribute those, what do I get? I get sine theta over cosine theta plus cosine theta over cosine theta. And again, you're not getting points by, like, some people might look at this and be able to just jump to this, but you want to show explicitly each step that you're doing. You don't get credit for just writing this, the right-hand side down in this case. All right, so sine over cosine, cosine theta over sine theta over cosine theta is tangent theta. So I can replace that with tangent theta, and then cosine theta over cosine theta is just 1. And so that is the right-hand side. Yes, it says 1 plus tangent theta, and I wrote it as tangent theta plus 1. That doesn't matter. So we know that that is the same. A commutative property of addition, I don't know. I haven't looked at the rules for Algebra 1 in a long time. But yeah, I think a commutative property of addition. All right, so yes, if you had to, you could say 1 plus tangent theta, but I'm not that much of a stickler, so you can stop there and say, yeah, those are equivalent. All right, number 3. So clearly there's one side that's more complicated. That's the left-hand side. So we're going to start with the left-hand side again. And then think about what you might want to do. In this case, I don't see any, identities, no Pythagorean identities are showing up. So I might want to turn everything into sines and cosines. So that gives me sine x, and then tangent, that's sine x over cosine x, and then plus cosine x. I can certainly put these together, multiply them. That gives me sine squared x over cosine x plus cosine x. And now what I could do is multiply top and bottom here by cosine x, so I can get, because this is over 1, so I want to get common denominator, so cosine multiplied by cosine x over cosine x. All right, and then that gives me sine squared x plus cosine squared x over the common denominator of just cosine x. And then sine squared x plus cosine squared x is just 1, so we have 1 over cosine x, and that is equal to, using the reciprocal identity, that's equal to secant x, which is what the right-hand side is. All right, so I mean, I would sort of be like, don't skip many of these steps. Sometimes you might be able to kind of say, oh, well, that's sine x over cosine, sine squared x over cosine, but be explicit. Show, again, some of you might be able to visualize this as being equal to this. Oh, it's obvious, but it's not, because I can't get into your mind to see it. So show each step explicitly. All right, don't jump over, because remember, I'm essentially giving you the answer. It's right here. It's secant x. So you're not going to get a lot of points just for writing secant x. You've got to show me that that you know all the steps that was required to get in there. All right, let's go on to number 4. All right, so pause the video, try number 4, and then start the video back up. All right, so I think, again, most of these I seem to have written so that the left-hand side is the more complicated one. It's not always going to be the case, but again, I'm going to start with the left-hand side. Everything's already sines and cosines, so there's nothing really to do there. But let's think about what we could do on the left-hand side. I could certainly factor a sine x out. So if I factor out a sine x, that leaves me with 1 minus cosine squared x. And then think about, can I write either of those as something else? This is a version of our Pythagorean identity. So I could replace that. I'm going to do sine x times, this is sine squared x. And then we can multiply those together, and that's sine cubed x. And that's exactly what remember, it's sine cubed x. That's really equal to sine of x quantity cubed, but we denote it, we write it more, simply without the parentheses. This and that mean the same thing. Okay. And again, some of you can kind of visualize that from here to here, but again, I'm giving you the answer, so be explicit, show that you understand that I could replace 1 minus cosine squared x with a sine squared x, and then go to the last step. All right, number 5. All right, on number 5, I am going to, I think, start, this side looks a little bit more complicated than that side. So I'm going to start with the left-hand side, again, on this one. And again, if you haven't tried this on your own, pause the video before you watch me do it. This is a difference of perfect squares. So I'm going to, I think, factor that. We get sine squared x plus cosine squared x times the quantity sine squared x minus cosine squared x. And, I can replace this with a 1. All right, so that's 1 times sine squared x minus cosine squared x. And so it's sometimes, even though we can't touch the right side, we can kind of look at it and say, okay, well, where do we want to go? We want just cosine. We want to get rid of the sine. So what could we do? What could we replace sine squared x with to give me cosines? And so I'm just going to ignore the 1 out in front, right? The coefficient, we can forget that. And so sine squared, using our identity, right? So using this identity, I could move the cosine over to the other side. So sine squared x could be written as 1 minus cosine squared x, and then minus another cosine squared x. So I've taken the sine squared x and replaced it with 1 minus cosine squared x, a version of our Pythagorean identity. And now I can just combine like terms. So this is 1 minus 2 cosine squared x. And that is what we wanted on the right-hand side. So we're good. All right, number 6. So number 6, you're almost, they're almost both sort of equally, I guess, complicated. But, this has 3 terms and has a 4th power, so I'm going to start with the left-hand side. Again, pause the video, try it on your own. All right, so I'm going to start with the left-hand side. And I'm going to go ahead and I think maybe try to factor this. So think of it, if you need to, as, 2u to the 4th minus 3u squared plus 1. And think about what would that factor as. It's almost a quadratic form. So I'm going to say 2 sine squared theta and probably a sine squared theta. And then, it's a 1, so it's going to be a 1 and a 1. They both got to be the same, because it's plus, and they both have to be negative. And so let's see if that gives us what we want. This gives us negative 2 sine squared theta. This gives me a negative 1 sine squared theta for a total of negative 3 sine squared theta. So that looks like it factors properly. And then, you sort of want to be thinking about where you want to go here. And think about maybe this here. What could we replace this with? And that would be a version of our identity, right? So think about that. Think about what we could do with this, right? So we could bring the 1 over, it'd be minus, move the cosine over, cosine squared over. So I'm going to leave the first thing, I think, alone for right now. And we could turn this into the negative cosine squared theta. And then think about where we want to go. We could distribute this and see, that seems like it would be that, right? So I distribute this, that's going to be negative 2 sine squared theta cosine squared theta. That's this term. And then I distribute this, I get plus cosine squared theta. And you could stop at that point, but you could see that that's the same as this. Right? We could, if you wanted to, rewrite it cosine squared theta minus 2 sine squared theta cosine squared theta. but sure enough, that's the same thing. Okay? All right, next one. Number 7. So again, pause the video, try that one. I think in this case, I mean, I think you could be equally successful with this, whether you start with the left or the right. Let's start with the right-hand side. All right, so what can I do with this right-hand side? Remember, one thing that we do if we can't do anything else is we turn them into sines and cosines. So that's 1 over cosine theta plus sine theta over cosine theta. And then we could combine those. So that's going to be 1 plus sine theta over cosine theta. And that's exactly what the right-hand side is. All right, if we start it with the left-hand side, we would do 1 plus sine theta over cosine theta. Well, I could break that into 2, right? So that's 1 over cosine theta plus sine theta over cosine theta. Usually I work down. I'm not sure why I worked across there. And then we can convert that. 1 over cosine, that's secant theta. Again, you're going to want to be looking at where you're going, right? So, I can turn this into secant theta, which is what I want. And then sine theta over cosine theta, that's tangent theta. Okay? So again, even though you're not allowed to touch the other side, you still want to be looking at it and seeing like, am I getting there? Like, what can I do to what I have to get what I need? And in this case, it was pretty simple. Just use your reciprocal identities and your quotient identity. Okay, let's go to number 8. I think everyone would agree that the left-hand side is more complicated here. We definitely don't want to turn this into this. It's much easier to turn the more complicated thing into the simpler side. So we definitely want to start with the left-hand side. All right, pause this video if you haven't already, and work on that. All right, with this one, they're already in terms of sines and cosines. There's no real identities to use. I think let's try to actually add these two fractions up. So let's multiply top and bottom by cosine. So we get, I'm going to do cosine squared theta over cosine theta times 1 minus sine theta. And then this will multiply top and bottom by 1 minus sine. So that gives us 1 minus sine theta quantity squared over the cosine theta. I'm using thetas. I switched from x's to thetas. Okay, well, I'll just leave them as thetas. Cosine theta, and then 1 minus sine theta. All right, so now I have a common denominator. And then I can try to simplify the tops. Now, I would say at this point, don't distribute these. It's tempting to go ahead and write it as cosine minus cosine theta minus sine theta cosine theta, but leave them for right now because we might be able to cancel something. And you could see for a minute, if you look at where we're going, we want secant. So that's a cosine downstairs would be good. So we want to be able to get rid of this 1 minus sine. So we're hoping that we'll be able to cancel something. Okay, remember, don't cancel one of them here with this. We need a common denominator that is the same. So don't go backwards. All right, so let's start simplifying the top of this thing. We have cosine squared theta. And then you want to FOIL this one out. So that's going to be 1 minus 2 sine theta. And then plus sine squared theta over cosine theta. And remember, don't distribute this one yet. Our hope is probably that we're going to be able to cancel this with something up above. because that will leave us with a cosine downstairs, which would end up being our secant. Okay. Okay, so this and this together give us 1. So I could replace that with 1. So maybe I could just go ahead and say that's 1 plus that 1, and I'm going to write that as 2 minus 2 sine theta over cosine theta 1 minus sine theta. Sort of running out of room here. I should have written smaller. And now I'll factor a 2 out. So let me right over here. We have 2, 1 minus sine theta, factoring that 2 out of the numerator, over, and again, still leaving this in factored form on the bottom. And now you can see that this will cancel with this, leaving us with 2 over cosine theta, which is the same as 2 times secant theta. Of course, I wrote thetas instead of x, but same thing. Okay, so that is what we wanted the right-hand side to be. So that one was probably the most complicated so far. All right, try the next one. And, kind of a toss-up whether we use the left side or the right side, but pause the video and try that one. I'm going to use the left-hand side. All right, so left-hand side, and this is one that we haven't done yet before. So there's sort of a little trick that we mentioned at the beginning of this video that might be useful here. So sine x over, I'm just going to rewrite it, 1 minus sine x. All right, so often it will be helpful to multiply the top and bottom of this by the conjugate of the denominator. So try that. So 1 plus sine x over itself. All right, and then what does that give us on the bottom? That's the conjugates. Remember, the center term is going to go away, so that's 1 minus sine squared theta, x. 1 minus sine squared x, which is kind of nice if you think about, yes, we're not allowed to touch this, but this is 1 over cosine. And this has a cosine x on the bottom, right? So we can think about, we could turn that into a cosine pretty easily, I think. Let's not distribute the cosine x upstairs yet, until we know whether something's going to cancel or not. If it cancels, generally canceling it in factored form sometimes is more helpful than in simplified. All right, so what can I replace 1 minus sine squared x with? Remember, I'm looking for cosines. Both of these have cosines in the denominator. Well, 1 minus sine, that's a version of cosine. A version of a Pythagorean theorem. So I could replace that with cosine squared theta, cosine squared x, sorry. And I have a cosine x up above, 1 plus sine x. So one of these will cancel with us. So this goes away and this becomes a 1. And then really I can break that into 2. So I can say that's 1 over cosine x plus sine x over cosine x, sort of running out of room here, but this becomes then secant x, and then this is tangent x. And that is what we're hoping the right-hand side would be, so we're good. Okay, so again, helpful if you kind of think about where you're going. I knew I needed cosines downstairs. This sine squared isn't going to help me. I can replace that using my identity. Remember, this identity here, I could move the sine to the other side this time, and cosine squared theta would be equal to 1 minus sine squared theta. And so that's what I did here. I replaced 1 minus sine squared x with cosine squared x. And then, of course, sometimes you want to hold off on simplifying, distributing, because if I'm going to cancel, I would want to cancel that in factored form. It's a little bit easier. Okay, so here are the two assignments, depending on whether this is the first day or the second day. Those are the notes. Again, this stuff does not really have a lot of the identities. The first one, 721, is dealing with more like just simplifying expressions like we saw in section 7.1. The identities that like we did here in this video is more seen in the second homework assignment.